O-rings are the universal seal throughout the world. However, there are some applications which may benefit from a different profile. This training video introduces a robust alternative to the O-ring, the double chamfer radial seal. First, let's define radial seal. Radial implies the seal is being compressed from inside to outside. Sometimes this type of sealing is called inner or outer sealing. It may also be called a rod or female seal, or a piston or male seal. In essence, a radial seal is placed in a groove either around a piston or in a groove inside a bore. Unlike an O-ring, the cross-section of the double chamfer radial seal has two flat sealing surfaces, and opposite of the groove, they are angled for easier installation. Double chamfer radial seals will fit in both a male groove around a piston or in a female groove inside a bore. Double chamfer radial seals have several advantages. One advantage is for when the O-ring fails by spiraling during installation or in a reciprocating application. The wide, flat base of the double chamfer makes it more resistant to rolling, and therefore a solution for O-ring spiral failure. A second advantage is for high pressure or large clearance gap applications, which can result in an extruded O-ring. A common solution is to add a backup ring as a support to the O-ring. The backup ring is a great solution. However, this can add complexity in several ways. 1, it adds more items to the bill of materials. 2, it can be difficult to install, becoming damaged. Finally, if the backup is forgotten or incorrectly assembled during installation, the O-ring will quickly extrude, resulting in leakage. A high-pressure, high-temperature double chamfer radial seal replaces the O-ring and backup combination with a single sealing solution. In addition, known issues with scarf-cut backup rings are the chance of the scarf area damaging the O-ring. By eliminating the scarfed backup, we are eliminating a possible failure mode. A third advantage has to do with the available groove space on the hardware. Standard O-rings require a specific groove depth and width, which can be difficult in tight locations or with limited hardware space. Since double chamfer radial seals are easily customized, they can be designed for a more shallow groove and seal just as well as an O-ring. Double chamfer radial seals are easily customized in both size and material for any application. For example, since the product is extruded rather than molded, the custom sizes will likely not need a costly mold, and instead use existing extrusion tooling configured for the desired size. And since the double chamfer radial seal is extruded rather than molded, there is no parting line on the finished product. This can be an advantage for gaseous or vacuum applications when even the smallest change in sealing surface will create a leak path. Another feature of the double chamfer radial seal is the ability to color code the outer diameter or inner diameter for visibility of proper installation. Double chamfer radial seals can be as small as an inner diameter of 0.5 inches or have an outer diameter as large as 18 inches, which means most every groove can retrofit from an O-ring. The seal height, also called wall, and width, also called cut, can also be adjusted. The design criteria for a double chamfer radial seal will be identical to an O-ring. The compression, also called squeeze, the gland fill, or also called volume fill, and stretch can be referenced in the O-ring handbook under the appropriate static or dynamic sections. Certainly, Parker application engineers are happy to assist with the right design for an application as well. To summarize, some key takeaways for the double chamfer radial seal training are: 1. They can solve the issue of an O-ring rolling in a reciprocating groove. 2. They can replace an O-ring and backup assembly for easier bill of materials and even possibly reducing damage caused by scarf cuts. And 3. Easy size customization and color coding can be an assembly solution for incorrect O-ring installation. Thank you for completing this Parker training video. If you have any further questions, please check out www.parkerorings.com and chat with an engineer.